This video will be solving equations that contain rational expressions. Now, to this point, all we've done so far is simplify rational expressions. For instance, if we had this rational expression, it would have been factor down the denominator, get the common denominator, multiply to get your correct numerator, and then combine like terms. And we would have been left with simply another rational expression. That's the best we would have been able to come up with. Now we're going to be solving equations that contain rational expressions. So now we have something that looks like this. Now we have an equation, x squared minus 9x over minus 43 over 2x squared minus 7x minus 4 plus 7 over x minus 4 equals 6 over 2x plus 1. All three of those fractions are rational expressions. What makes this an equation is the equals sign. If it's an equals something, then it's an equation. Equations equal something. Okay. So now instead of just simplifying and coming up with a rational expression, we're going to be trying to completely solve and figure out exactly what does x equal. What number or value is x equal to? And that's very different than what we've done so far. And in fact, it's actually quite simple. Our process for solving equations that contain rational expressions is to remember that they are fractions. A rational expression is anything that can be written as a fraction. So we're going to multiply everything by the common denominator. And by common denominator, I'm talking about all the denominators on both sides of the equation. We're going to multiply everything by the common denominator formed by all the denominators. Then we're going to solve whatever we have. We'll combine following the order of operations. We'll solve it. And then it's very important that we check. And we'll see why it's so important to check in just a moment. So with this equation here, first thing we need to do is multiply everything by the common denominator. But in order to find the common denominator, just like before when we were simplifying expressions, we need to factor things down. When we factor down the only denominator that can be factored down, in fact the only thing that can be factored down, because that polynomial in the numerator is non-factorable, we get the 2x plus 1 times x minus 4. So we compare all the denominators and look for what would be the common denominator, or the least common multiple. And in this case, it's going to be the 2x plus 1 and the x minus 4. So we multiply everything by that common denominator. Now some people will say multiply both sides of the equation by the common denominator, and that is true. There's nothing wrong with that. The problem I have with that terminology is when people do that and they find that they need to distribute, they don't distribute correctly. So I always say just multiply everything by the common denominator, then you don't have the problem of distribution errors. So when we multiply everything by the common denominator, we will see that the 2x plus 1 and the 2x plus 1 cancel. The x minus 4 and the x minus 4 cancel. This x minus 4 and that x minus 4 cancel. And this 2x plus 1 and that 2x plus 1 cancel. And that's going to leave us with, in the first rational expression here, only the numerator, x squared minus 9x minus 43. With the next rational expression, we'll be left with 7 times the quantity, 2x plus 1. And with the last rational expression, we'll be left with 6 times the quantity, x minus 4. Now, for those of you that hate fractions, you might look at this and rejoice because there are no more fractions. They have all been eliminated. That's the result of multiplying by the common denominator. All the denominators end up getting canceled, and you're left with just a simple equation. So at this point, we combine, we distribute, we solve it in whatever manner that it needs to be solved. In this case, it's an x squared equation, so we're going to be factoring and setting it equal to 0 and all that kind of setting it equal to 0 and then factoring. First, we distribute, combine like terms, set it equal to 0. Factor, set the factors equal to 0, and solve. Before we give our solution, though, it's absolutely essential that we check. Because remember that our problem started as a rational expression, several rational expressions in this case. And rational expressions cannot have zeros in the denominator. Now we manipulated our original equation to get rid of all those denominators so we could work it without having to worry about it. But we do need to remember they did in fact start with denominators, and we need to make sure there's never a zero in the denominator. So we check. Well, the -3 is not going to put a zero in the denominator, but this 4, if it's put in that denominator, 4 minus 4 will be 0. So we cannot use the x equals 4 as a solution, and we're left with just the solution of x equals -3. That's it. That is solving equations with rational expressions. You've done all of it already. Find the common denominator. Sometimes that may involve doing some factoring. Multiply everything by the common denominator, which is simply going to be a bunch of canceling. And then you're going to be left with an equation with no denominators. Distribute, combine like terms. If it's an x squared, solve by factoring. If it's not an x squared, just simply isolate the variable. When you get your solution, regardless of your method, when you get your answers, check them to make sure they don't put a zero in the denominator. That's the only really new thing here, is to make sure you don't have a zero in the denominator. And then any solutions that remain are your answer. If all the solutions would put zeros in the denominator, then you have no solution. It's just that simple. So looking at the steps again, they're fractions. Multiply everything by the common denominator. Combine following order of operations, solve it, and check it. That's it. Thank you very much.